Hello everyone, welcome back to iQuanta. So I've started with number system playlist and today I'll be talking about HCF and LCM in this topic. So what is HCF? What is LCM? This is something you guys must have studied in class 4th or 5th. So we are going to talk about the basics and then we will go to CAT level questions. So what exactly is HCF? It consists of 3 words and we will discuss each word in detail. Highest common factor. So suppose if I take two numbers 12 and 18. So what are the factors of 12? Simply 1, 2, 3, 4, 6 and 12. What are the factors of 18? Right? Now second word is common factor. So common factor you can see 1, 2, 3 and 6. And the third one is highest. So highest common factor will be 6. So can I say the HCF will be 6? Or in a simple language, if I try to decode this, 6 is the greatest number that divides given numbers completely, right? The same thing I have written here, I will discuss this later. But as of now, 6 is the greatest number, or you can say greatest factor that divides given number completely. Now let's understand LCM as well. Least common multiple. So what are the multiples? Let's take this same example. So multiples, if I read the table of 12, 24, 36, 48, 60, 72 and so on and so forth, all these are multiples of 12. Similarly, 18, 36, 54, 72, 90, all these are multiples of 18. So there is a huge difference between factors and multiples. So never get confused, okay? Now, common multiples 36, 72 and the least common multiple, that is 36. So basically, if I try to decode these two terms in a simpler language, so HCF is a number which divides the given number. HCF, it is a number which divides the given numbers. That's why HCF is always less than or equal to given numbers. LCM is a number by which other number get divided. So you can understand it, it is in the form of grammar also, it is active passive voice relation, right? It is something which divides, it is something by which other number get divided by. So LCM is always greater than equal to given numbers. Now let's go to definition of each and every term and let's see few application based question or definition based question of each and every topic. So first we will understand the definition of HCF, then we will solve few questions related to HCF, then we will move on to LCM and we will see few definition based questions of LCM. Now what is HCF? I have already told you it is the highest number that divides given numbers completely. Now when it comes to remainder, so remainder is something whenever you divide one number by another number, if it is divisible, you get remainder as 0. But if it is not divisible, you get some remainder, right? Since HCF is the number which divides the given number completely, so can I say my remainder will be 0, right? So same thing I have written here also, HCF is the greatest number that divide given number and leaves remainder 0. The reason of discussing remainder in HCF because the question comes like where remainder is always included when it comes to HCF and LCM. So we need to understand remainder also with respect to HCF and LCM. So I hope this part is clear. Now we're gonna solve few questions related to this definition. Let's begin with the first question. Find the highest number that leaves remainder 0 when it divides 36, 48, 120. So clearly it is asking you to find out the HCF of these three numbers. So HCF will be 12, but those who do not know, they can find out with the help of this method, which you must have studied in class 4th and 5th. So first you take 2 common, then 3 common, and so on and so forth. I would recommend you to try to take a bigger number common, right? So can you see, if you are comfortable with the table, you can see within seconds. So these 3 numbers are multiple of 12. So I will directly take 12 common. Here 3, here 4, here 10. Now you can check among these 3 numbers there is nothing common. So that's why the HCF will be 12, right? Now let's move on to the next interesting question. Please focus on this question. Find the highest number that leaves remainder 1 when it divides 37, 49 and 121. So question clearly says when it divides 37, it leaves a remainder of 1. So can I say it divides 36 completely? Because when we are dividing 37, we are getting remainder as 1. So clearly means it is dividing 36 completely. Similarly, when we divide, it gives a remainder of 1. So I can say it divides 48 completely. Same goes for 121. It divides 120 completely. Now instead of solving for remainder 1, what we did, we have decoded this question in our form. That means we have to find out a greatest number which divides 36, 48 and 120 completely. So my question becomes HCF of 36, 48, 120. So what we did basically, if you observe, we did this. That's it. So next time whenever you find a remainder with respect to HCF, you have to subtract that remainder. That's it. And we already know the answer of this particular problem is 12 because we have already solved. Now next question. I would ask you to solve this question by yourself, and you can pause the video, solve this question, comment down your answer. So we are getting different remainder, but we do not need to get confused. With respect to 37, we are getting one remainder. So 37 minus 1, 50 minus 2, and 123 minus 3. So HCF of 36, 48 and 120. Answer is again 12. So I have intentionally taken these 3 numbers to make you understand the application of definition based problem related to HCF. Now, the fourth one is the very important one question. Please focus on this. So we have covered 3 types of question as of now. First one where remainder was 0. Second time remainder was something, but remainder was same for each and every case. Third, when the remainders are different. Now the fourth case is we have to find out the HCF, but here remainder is also unknown. Leaves same remainder, but we do not know what is that remainder. It can be 1, 2, 3, can be anything. So whenever you see a question based on HCF and remainder is not known to us, you have to simply do what I am teaching you. So numbers are 36, 71, 141. So I am discussing a shortcut which will save a lot of time, right? So there are 3 numbers given to us. Just make 2 pairs. Pair 1, pair 2. Now what you have to do? Take the difference of these pair. Okay, and HCF. First step, make 2 pairs. Since there are 3 numbers, you will be able to make only 2 pairs. If there were 4 numbers, you would have made 3 pairs. Okay, so now you have to take the difference of those pairs and then HCF, and you will get your answer. So HCF of 35 and 70, that is 35. So this will be your answer. And if question setter asks you what will be the remainder, what is that same remainder, what you have to do? Just divide any number by this HCF. So 1 is particular remainder which is common every time, right? So 1 is the remainder, 35 is the answer for this particular question. Next part. Next, let's talk about LCM. So we have covered HCF definition related problem. Now we are gonna solve, or we're gonna talk about LCM related problems. So LCM, it is a least number which is divisible by given numbers, or it is a least number which leaves remainder 0 when divided by the given numbers, right? HCF is a number which divides LCM, by which other number get divided. I hope the difference is clear. Now, let's see first question. Find the least number which leaves remainder 0 when divided by 8, 12 and 32. So what you have to do? You have to take LCM, right? And how to do that? Can you see anything common? I can see 4 common. Can you see something more common? Yeah, 2. Now, there is nothing common. So, whenever you see there is nothing common between the numbers, just multiply. So, 4 into 2 into 3 into 4. 96 will be the LCM. Just a second. Okay. So, 96 will be the LCM of this particular question, or answer will be 96. So, question setter, what question setter usually does, they try to confuse you by mixing some kind of definition in a basic problem. You have to stick to your concept. If you are sticking to your concept, you would never get confused. Let's move on to the next question. So, next question is find the least number which leaves remainder 1 when divided by 8, 12 and 32. So, what we have to do? First of all, we have to take LCM of 8, 12 and 32, which we have already taken in the previous question as well, that was 96. Now, if you try to understand this question with the previous one, in the previous one you were getting remainder as 0, so my answer was 96. But here the remainder is coming out as 1. So that means this number will give us a remainder 0 when divided by 8, 12 and 32. But we need to have remainder 1. So what we have to do? Just add 1 in the final answer. So 97 will be the right answer. So during the case of LCM, what you have to do? You have to add your remainder in the final answer. Okay? Let's check one more question on the same concept. Find all the numbers less than 500 which leaves remainder 1 when divided by 8, 12 and 32. So first step, LCM, which was 96, right? Now, question says we have to find out all the numbers which are less than 500 and satisfy this particular condition. So what you have to do? First step is finding out LCM. Second, then find all multiples of LCM. Why? You would understand. So 96 is the least number which satisfy this condition if the remainder was 0. Next number will be 96 into 2, 192. Again, this will give us remainder 0. 96 into 3, 288. 96 into 4, 384. 96 into 5, 480. All these numbers will give us remainder 0. Now what we have to do? We have to add remainder 1 to get the final answer. So my final numbers will be these. So third step, always remember, add remainder at last. Okay? Next question. Find the smallest 4-digit number which leaves remainder 5 when divided by 12, 18, 24. So question has been changed slightly. Numbers were 8, 12 and 32, but here numbers are 12, 18, 24. So first of all, we have to find out the LCM. So how we can do that? Same method. 12, 18, 24. Okay, so first you can see 6 common. So 2, 3, 4. You can take 2 common, 1, 3, 2. Now, you can clearly see there is nothing common, so we can multiply everything. 6 into 2 into 3 into 2, that is 72. So 72 is the least number which satisfies this particular condition, right? But question says you have to find out the smallest 4-digit number as well as add the remainder. So first of all, what we will do, we will go near to this particular number. How? Just divide the LCM, because we have to find out the multiple of 72 which is close to 1000. So how do we know about it? Just simply divide 1000 by 72. This is 280. So because 4 will go, you can check for 4 also. You can see 4 will go outside this range. That means it will be more than 1000, right? And if I look at 3, that number will be less than 1000. But obviously we have to find out number which is more than 1000, right? Not less than 1000, because we have to find out smallest 4-digit number. So we got to know there is 8 extra. I need 8 more because this number contains 280, but I need 8 more. So 1000 should be 1000 plus 8, 1008. Or you could have done 72 into 14. In this way also you could have reached to 1008. So 1008 is the least or smallest 4-digit number which is a multiple of 72. Now you have to add remainder. So final answer is, guys, 1013. Next, find all the numbers between 200 and 500 which leaves remainder 1 when divided by 2, 3, 4, 5, 6. First step, LCM. I hope you can take the LCM. LCM will be 60. Now, you have to find out the multiples which are in this range. So 6 की table सबको आती है. So 60 into 3 is 180. We cannot consider this. 60 into 4, 240. Possible. 300, 360, 420, 480. But after that, not possible. So there are 5 such numbers, right? Now what we have to do? We have to add one remainder. यही गलती नहीं करनी है. So 241, 301, 361, 421 and 481. All these 5 numbers will be our answer. Next, find the smallest number which leaves remainder 1 when divided by 2, 3, 4, 5, 6 but divisible by 7. So it's a very good question. I have seen a lot of students get it wrong. You can also try. You can just pause the video and try to solve this question by yourself, and if you get it right, kindly mention this in the comment section. So first step is LCM. LCM of 2, 3, 4, 5, 6. Now let's understand the meaning of this question first. You have to find out a number which leaves remainder 1 when divided by 2, 3, 4, 5, 6, and this number is a multiple of 7 also. So this is not complete question like that. There are 2 types of question which are included and were made into one question. Those 2 questions were, first, a number which leaves a remainder 1 and when divided by 2, 3, 4, 5, 6. And second question was, there is a number which is a multiple of 7. Now question creator has mixed these 2 questions. So you have to solve them individually. First I am solving till this part. Okay. So LCM of 2, 3, 4, 5, 6, that is 60 and remainder 1. So smallest number will be 61. Now I have to check whether this number is a multiple of 7 or not. No. Now what we will do? We will go for next multiple of LCM, that is 120 plus 1, 121. No. 180 plus 1, 181. No. 240 plus 1, 241. No. 300 plus 1, 301 divided by 7. Yes. So answer for this question will be 301. Next. So till now I have covered few questions of LCM, but every time the remainder was same. What if remainder is different? So it's a beautiful question on that part. So when we are dividing by 8, we are getting remainder as 7. When we are dividing by 12, we are getting remainder as 11. When we are dividing by 32, we are getting remainder as 31. So we can see there are positive remainders, and these positive remainders are different. So whenever you get remainders as different, just go to the negative remainder. So if positive remainder is 7, 11 and 31, what will be the negative remainder? -1, because 7 is being divided by 8. So 7 has 7 extra. That's why it is not divisible by 8. Also, you can say 7 has 1 less. If 7 would have been 8, it would have been divisible by 8. So 7 has 1 less. So that's why negative remainder is -1. Similarly, 11 has 1 less with respect to 12. 31 has 1 less with respect to 32. So in terms of negative remainder, we are getting the same value. So what we have to do? We have to take LCM of divisors and plus our remainder. That's it. So 96 minus 1, 95. And you can cross check also. Let me show. When we divide 95 by 8, you can check 7 is the remainder. Similarly, you can check for with respect to 12 and 32. You will always get the same values, right? So best part about LCM question is you can also cross check whenever you are in a doubt. Now, this is a little bit difficult question. I would ask everyone to pause the video and try to solve this question and kindly mention if you get it correct. So this time we are dividing by 2, we are getting remainder 1, 4, 3, 6, 5, 8, 7. So positive remainders are different. So what we have to do? We have to go to the negative remainder. -1, -1, -1, -1. This is negative. So LCM of 2, 4, 6, 8 -1. That will give you the least number. 24 minus 1, 23. But question setter is asking for the all the values which are less than 200. Now what we have to do? Simply, just a second guys. So we have to see all the multiples of 24 which are less than 200. So 24, 48, 72, 96, 120, 144, 168, 192. After that, the multiples will be more than 200. So there are 8 multiples minus 1. So in exam, question will be how many such numbers are possible. So answer will be 8. But as of now, to make you understand the concept, I am discussing everything in detail. Don't worry guys, in the next session, I am gonna discuss all the questions with the help of options so that you get an idea what type of questions comes in exam. In this video, we have just learned the concepts. In the next video, we will solve a lot of questions based on HCF and LCM. This is about our course. You can check. We have a live and conceptual classes followed by application classes. Application classes is always been iQuanta's X factor because live and conceptual classes तो आपको और भी कोचिंग में मिल जाती हैं, बट जब उसकी ही अगर एप्लीकेशन करने को मिल जाए और जो भी आपने सीखा है उसके ऊपर ही अगर आपको पैरेलली कुछ और अच्छे क्वालिटी क्वेश्चन या कैट लेवल क्वेश्चंस मिल जाते हैं तो वो आपकी प्रिपरेशन को और बेस्ट बना देता है. Apart from this, we have few modules. First is non-engineer, which is specifically designed for those who have weaker maths, and this is for those जिनको एक ही जगह पे सारे शॉर्टकट्स चाहिए, सारे शॉर्टकट्स को रिवाइज करके अपनी प्रिपरेशन को बेटर बना सकते हैं, तो उनके लिए कट शॉर्ट मॉड्यूल है जो हमारा एक एडवांस मॉड्यूल रहता है. दिस इज बेसिक, दिस इज एडवांस. And this is our course details, which you can check out on our website also. So that's all in this video, guys. We will meet in the next video and we will solve a lot of question on HCF and LCM.